Welcome. This is Convergence. My name is Michael Doran. I'm a California attorney. Don't have a dog in the fight. Albert Einstein once stated that among the most difficult problems in all of physics is the Earth's magnetic field. As a California lawyer who's been involved in the debate over climate change for 25 years in various places across the internet, I argue that the Earth's magnetic field is among the most difficult problems in all of biology. Today I want to talk about a couple of things. I want to talk about a lightning complex related to the McKinney fire in Northern California called the SRF lightning complex. When my daughter was an idea 22 years ago or so, we went camping and to the Redwood Forest. It's among the most beautiful places. There's a place called Thompson Beach. Just take your breath away. But one thing that I learned then was that the Great Redwood Forest has been whittled away to about 5% of what it was. On top of that, there have been dams built on the Klamath River, and all really up and down the west coast dams have been built. On top of that, fossil fertilizers are being used around the globe. And the biosphere is just amazingly resilient, and it's just like when you talk about cancer and we are looking for oncogenes, what are the genes that are defective that are causing the cancer. We've learned that it's not just one gene, but it's many genes. And in this case, there's a number of things that are going on simultaneously to produce a result. And right now, we're in the midst of a relatively low period of solar activity, but it's starting to ramp up. So I know I'm bouncing all over. We had this Hurricane Frank that went through the Eastern Pacific, and we've had a number of storms. So if F is Frank, that's the F storm. We've had a number of storms in the Eastern Pacific, and not so much so in the Atlantic. Some of my chaser friends are getting a little bit antsy. Well, this pattern that we're seeing is no accident. It's a feedback. So what happens is when a tropical storm goes through the oceans, there was a study on Hurricane Felix in 2001 that found that 25% or a third, I'm sorry, I don't have that one right at the tip of my head, but tremendous amount of the ocean's carbonation was removed by Hurricane Felix when it passed by. And the same thing occurs when Frank went by the Eastern Pacific. What the same people who studied Felix found is that it takes about 2 weeks for the carbonation levels to come back just from the ambient levels of CO2 in the air. But when that storm goes by, it's just like opening up a soda or a beer or whatever after you've shaken it. So you get the winds that are twirling around, the tropical forest winds or hurricane force winds that are twirling around, and then you get the lower pressure of the storm right on the ocean, and it's just like opening up a soda after you've shaken it. The CO2 comes out, goes into the clouds, and then affects their microphysics in the context of large-scale electrical fields. And basically the way I've explained it before is in these fields, the acid of the carbonic or carbonic acid makes the cloud droplets that are freezing asymmetrical. And the shape of those clouds affects then the rate at which freezing in mass occurs, and hence the rate at which phase change occurs. And when a water droplet turns from water to ice, those phase change energies, they're called delta energies, heat up the parcel there, make it expand and make it rise relative to the storm, and you get stacking and an electrical enhancement related to carbonation. Well, the same thing occurs with other features that have to do with carbonation. And right now, as we speak, the National Hurricane Center is looking at an invest that's in the Eastern Pacific, and they're calling for it to turn into a tropical storm. Now, Frank, which 10 days ago turned into a tropical storm, that's a little bit less than the 2 weeks it takes to decarbonate. But part of what's going on is when you have a tropical storm go by and roil the oceans up, it brings to the surface colder, nutrient-rich oceans that then are primed for biological activity, which further draws carbonation into the oceans. So this pattern is also a creation of electrical currents that flow relative to it and warm up conductive pathways in the subterranean. There's a number of things that are going on that cause a feedback for a pattern to recreate. And my chaser friends in the Atlantic are knowing what's going on. And meanwhile, there's this dead zone created by fossil fertilizers that are flowing down the Mississippi and other rivers. And there's seaweed everywhere, to the point where there's national emergencies being declared. There's smelly seaweed covered beaches that are normally pristine. And there's phytoplankton blooms in the Atlantic. What does that do to carbonation levels and then the mechanics? What does patterns set about do to upper level winds that make it hard for a tropical storm to stack? We're real early in the season. We're nowhere near the peak of it. As we get more into the fall, that's the spring for South America, and you get a lot of lightning there, and that lightning particularly is favorable to cause couplings over a warming Atlantic. So you've got a current, and then you've got a place where that current can go and cause a capacitive coupling. But right now, the Eastern Pacific is where it's at. That's where feedbacks are occurring, and that's where fires are occurring. And in this particular case, Pacific High right now is fairly healthy and big. So I went through the typical websites that I look at when I'm trying to see what the state of the conditions are. And one thing I noticed right away at the Worldwide Lightning Network is over the last 24 hours, there's been almost 730,000 total flashes per degree squared, and almost all of them are concentrated either in the monsoonal part of Mexico along its coast, and then the southeast, and then a little bit in the Dakotas and Minnesota. Last 24 hours, very active areas. And then there's a less active, but to me an extremely interesting area of lightning, which is downflow from these fires in Northern California. So that's kind of our setup. The other part of our setup here is that on the middle of August 3rd, no, I'm sorry, right before we turn to August 4th, so the end of August 3rd, there was a near M-class X-ray event, which again is high energy light that helps ionize the upper atmosphere and create electrons that are free to couple and form and organize about a tropical storm, or free to organize about a fire. And the last couple of days we've been here in California, there's been this fire called the McKinney Fire. A weird little story. As a lawyer, I sometimes appear up in Wairika and I was supposed to do a Zoom hearing in Wairika, and I called the court on Thursday, and I'm like on hold for 45 minutes, no meeting. Then I look on the web page, and the presiding judge, who I was about to appear in front of, had closed the court. So there was no hearings. I had told that judge a few weeks ago to come and watch my channel because I was talking about this. And sure enough, it's relevant to maybe a decision she made about the explosive nature of these fires. In fact, there was a recent scientific article about how these fires are going higher into the stratosphere, that the fire behaviors are not normal, that they've never seen fire behaviors like this. So then on a little bit in the early part of the 5th, we had another very big C-class X-ray, almost an M-class X-ray. And then current conditions, solar winds are at 384.2 kilometers per second. And what I always notice about that, it has to do typically with coronal holes and mass ejections. And if the mass ejections, the solar wind is less than 500 kilometers per second, that's conducive for formation. The density is a little on the high side, but it's under 500 kilometers per second. And I think the speed is really important in terms of disrupting organizations, electrical organizations over tropical storms. Also the neutron counts. So we've had this period of very high neutron counts, or basically cosmic rays. And to me, I think of them as basically protons. But in the last 48 hours, it's gone up almost a full percent to 3.1%, and that is considered elevated. And it's not as high as we've seen over the last 4 years as the sun has gone through this quiet cycle, but it's still up there. And consistent with that, I've noticed that there's a very healthy Pacific high, especially close to the fires, to the point where the winds from that Pacific high are so elevated, like 30 miles an hour or more, that there's a red flag warning about the area with active fires. I like to go to null, earth.nullschool.net, which shows surface winds, and then I blur it by moving my thumb over my cell phone, and then I can pick up undulations. There's clearly undulations over Invest 9, which the National Hurricane Center is calling for it to become a tropical storm tonight. I'm always skeptical of those calls. All it will take would be an X-ray event, and it'll be named. But if the X-ray event doesn't occur, it's still consistent with, it's a tropical depression right now, still consistent with this pattern that we're seeing, even though we're at day 10 instead of 2 weeks, allowing for recarbonation. There's tremendous amount of undulations along Baja that I can see with the blur null. There's particularly strong undulation that's associated with the Missouri, and it goes all the way up to Minnesota and through the Great Lakes. The other thing I saw, aside from the very large Pacific high, is an incredible undulation that's a little bit south of the Aleutians, paralleling it, really strong. And that helps to cause the wind microphysics to be such that, or the cloud microphysics to be such that winds get pushed into the Americas, and it's like a heat pump. It's like pumping up a bike. It's part of why that Pacific high is behaving like that. And I seem to see that a day or two after X-ray events like we just had. So this is all a consistent pattern that you're seeing in the Pacific itself, causing this red flag event, the way that Pacific eye is. And I see a similar set of undulations south of eastern Russia. Both the Aleutians in eastern Russia, in my view, act as large-scale antennas to help capture these Schumann resonance and then turn them into kind of wind behaviors that you can see with your own eyes on the null set. A particularly strong null set, null school, undulation crisscrossing the Missouri, South Dakota, and into Minnesota. And final undulation that is frankly amazing looking. If you get a chance, that you can go on earthnullschool.net, between South America, again, which acts as a large-scale antenna, and the peninsula of Antarctica, there is an incredible looking undulation. It's, you know, the Earth is round, and you get a screenshot of, you know, I call this show Convergence because technology is converging, and things like spatial computing have gotten incredible. Our cell phones, the computing side, speed has become incredible. So all these software design things that we've had in the past, the satellites that we have up, for you to pick up, you know, an undulation, a null skull, blur it a little bit, and I mean, there's no way that it defies Coriolis, everything, for you to have a straight line that goes right to the antenna feature of Antarctica, stops, doesn't go, it ends there, and it has a perfect, and I mean perfect sine wave going from the surface low all the way to the antenna feature. And there's, you know, these winds are coming to this area from different directions, and then it stops in a straight line. The only, if you pan out further, there's another massively long undulation that goes all the way to the tropics. There's just no way these phenomena can be explained by any other feature. So, also part of decarbonation is the McKinney fire, which straight puts carbonation into the air, and we've had incredible high clouds, ice crystals in those clouds, just like it was a tornadic cloud. We've had lightning in the area, downflow, where basically the smoke is. And so we also have this SRF lightning complex, which is associated with the South Fork and the Klamath River, which again are acting very much like giant antennas, the river systems do. And there's been problems with the Klamath in terms of it having a lot of algae, it being warm. Now the fire has killed a bunch of fish. Again, there's this context of the redwood forest being cut down mostly. When, not even 20 years ago, we went camping, and the joy of my life, my daughter was in the works. We tried to light fires at campsites with redwood, and it's the redwoods themselves generate a huge amount of their own moisture from fog because of their needles. It captures the fog and it drips on, so it doesn't have to rain for redwoods to get watered. They're designed for the environment, and the air is so humid that even when you try, I remember taking a blowtorch off of a propane can and trying to light the fire, and it wouldn't light because the air was so humid. But here we are with a fire, this SRF lightning complex. It's right on the edge of the redwood forest. None of that should be catching fire. It's just too, historically, it's just too moist. It's one of the reasons those giant trees grow the way they do, is because it just never gets dry enough for anything to burn. And here we are, that area is threatened, and the smoke cloud over that fire is again exhibiting these behaviors that we've been seeing, where the clouds form ice crystals, go up. It's an electrical phenomenon. It's the same reason that spiders can fly using electrostatics. The soot does the same thing. The embers do the same thing. The smoke cloud is doing the same thing. And it's part of an entire electrostatic order with a huge Pacific high that's, I think, benefiting from a little bit elevated cosmic rays. If we were to have any kind of X-ray event in the next day or so, you're going to for sure get crazy, even more intense fire behaviors over this complex, which was started by lightning. All the fires in Northern California are related. They're related to the decarbonation from the number of tropical storms that we've had here, and they're related to the fires that were in Yosemite, and first in New Mexico, and then Arizona, and then the ones around Yosemite. All of them are related and interconnected regionally to help carbonate the air, cause lightning, cause these tropical storms to occur. They decarbonate, and ultimately they're related to the low levels of the reservoirs, because these reservoirs are releasing during the dry season. And it looks to the nearshore biosphere as if snow is melting in the mountains. And that is met with a heat feedback, because, and then the dams also remove high levels of sedimentation, and you've got fossil fertilizers going down river again during the dry season, and the feedback is heat, because the mountains full of snow would do the same thing. They would bring cold, nutrient-rich water to the nearshore oceans, and the biosphere is concerned about snowball Earths. So over time, the feedback of heat has evolved. And this is very much about electrostatics. This is very much about the Earth's magnetic field. And on the flip side, the Atlantic is being very much, in my view, affected by dams as well. The Rio is all dammed up, obviously the Colorado, but fossil fertilizers, and then of course fossil fuels becomes a signal noise problem for these low pressure events that are supposed to have some sort of signal from the low pressure carbonating clouds. Well, if the ambient carbonation is already high, it's harder to get a signal to create a stability from the low pressure and from the regional lightning. So right now, it looks like we're going to have another tropical storm in the Eastern Pacific. It takes away from, there's a inverse relationship between Eastern Pacific activity and Atlantic activity, and we're getting a lot of Eastern Pacific activity. Once it gets rolling, the feedbacks are such. It comes where Lake Mead and Lake Powell are at record lows, and they're still releasing in the middle of the dry season. We have the Rio Grande de Santiago, which over the last 20 years has had massive dams. I think that affects California a lot. So by history, I think it's just really ironic that with Hoover Dam, we had this dust bowl, and a lot of people from Oklahoma and so forth came to California. They're called the Okies. And they came to California and settled down, and that was a result of the human activity related to Hoover Dam and how that affected these same processes, affected methane hydrates, and that occurred also during a solar minimum, the dust bowl, where a period of obviously high cosmic rays. And so now all these people that have settled in California, you've got some of the same issues now, but all in the context of widespread use of fossil fertilizers. And in the Gulf of Mexico, you've had a very strong phytoplankton bloom in a dead zone in the northern part of the Gulf, and now you're getting these reports of this seaweed in the Caribbean, and I believe that that is playing a big role, along with the fact that the electrical currents from lightning in general in the United States is basically being consumed by the storms in the Eastern Pacific. One more thing I noticed here, over the last couple days, as Frank moved, and its moisture and its remnants moved over California and Arizona and so forth, and there wasn't as much decarbonation going on, global lightning went down to like 670,000 strikes per degree squared. And right now it's up again to 730,000 strikes per degree squared over the last 24 hours. If you look at the up to the minute lightning, just kind of the network, the worldwide network at Washington University, you see very healthy lightning downflow from the fires in Northern California and also along the mountains along the west part of Mexico, and then you see the forming tropical depression right now. It might be, at the moment I took that picture, it might be a tropical storm. Researchers have known for a long time that tropical storms, when there's lightning in the middle of them, they're rapidly intensifying. And as I look at this spot image, there is lightning at storm center. That tells me that this storm could be rapidly intensifying with the peak of the lightning for the evening. So again, if you get a chance to go to the real-time part of the Washington University worldwide lightning network, downflow from the fires in Northern California, there's lightning, and then along the Mexican coast next to approximate to this forming tropical storm. It's the same pattern that we've seen basically all summer long. And the fires and the tropical storm patterns are all really consistent with the problem that we have with our dams in the Southwest. Appreciate your time. Thank you for watching. Click like if you like, subscribe if you like. Thank you very much for your time.